Welcome to AI Paperslap. Today we are extracting the absolute core of Google DeepMind's release announcements and the official model card for Gemini 3.5 Flash.
Yeah, we have a lot to cover.
Right, so here is your 1-minute summary so you know exactly what we are dealing with today. Gemini 3.5 Flash is a natively multimodal reasoning model.
And the raw specs are just, well, they're intense. It has a 1 million token input context window.
With a 64K output limit and a knowledge cutoff of January 2025.
Right. But its defining trait is really what DeepMind calls frontier intelligence with action.
Exactly. It outputs tokens 4 times faster than previous frontier models. This is not just a chatbot update, you know?
Yeah, not at all.
This is an engine specifically engineered for complex, long-horizon agentic workflows and, deep coding tasks.
Yeah, if you are building autonomous systems or deploying enterprise machine learning or trying to automate multi-step engineering pipelines, this architecture just completely changes the math on what you can build.
The math really does change here because DeepMind is essentially recognizing that if you want to deploy autonomous systems that actually execute tasks in the real world...
Right, you cannot be held hostage by a slow inference engine.
Exactly. The entire architecture of Gemini 3.5 Flash is built around this premise of high-speed parallel action.
And they build directly on the foundation of the Gemini 3 Flash model. But they didn't just scale up the parameters, they introduced dynamic thinking levels.
Wait, I need to stop you there. Thinking levels.
Yeah.
Does that mean I'm literally turning a dial on how smart the AI is, or is it just, I don't know, allocating more compute time? Because usually in AI, if you want a fast answer, you get the fast food version of intelligence, right? You sacrifice deep reasoning for low latency. How are they bypassing that traditional trade-off between speed and quality?
So think of it less like turning down a generic smart dial and more like a highly advanced routing system.
Okay.
These thinking levels allow developers to actively control the mix of quality, cost, and latency depending on the specific task.
Oh, I see.
Yeah, so if you have an agent doing a simple data extraction from 1,000 invoices, you don't need deep philosophical reasoning. You configure it for pure speed.
Right, that makes sense.
But if you have an agent parsing a complex cryptographic logic flaw, you allocate more compute to that specific node.
So you bypass the trade-off by not forcing the model to use its maximum computational weight on trivial steps.
Exactly.
That makes total sense for single prompts, but DeepMind is pushing this specifically for agentic workflows. Why is that raw token output speed, that 4 times faster metric, so critical when we talk about agents?
Well, we have to look at the mechanics of how an autonomous agent actually operates. I mean, an agent isn't just answering a single question.
Right.
It's engaged in iterative loops. Imagine an AI trying to fix a software bug.
Okay, I'm tracking.
It has to plan a step, write a block of code, run that code in a sandbox, read the resulting error message, update its internal plan, rewrite the code, and then run it again.
Basically having a conversation with the compiler.
Exactly. And in that conversation, latency compounds brutally.
Oh, yeah, bet.
Like if a model takes 15 seconds to output a response and an agentic workflow requires a 50-step loop to resolve that GitHub issue, that latency becomes a massive bottleneck.
You are waiting 20 minutes for a single bug fix.
Right. But by quadrupling the output speed, Gemini 3.5 Flash reduces that loop from 20 minutes to 5.
Wow.
That speed is what actually unlocks multi-step autonomous execution in real time. It shifts the paradigm from a slow script you run overnight to an interactive, real-time tool.
So if speed is the fundamental enabler of the architecture, we really need to put that intelligence claim to the test.
Let's do it.
Let's look at the technical benchmarks from the model card, because 3.5 Flash is actually beating the much heavier Gemini 3.1 Pro model in several key areas.
Yeah, the numbers are pretty wild.
For agentic terminal coding, specifically Terminal Bench 2.1, Gemini 3.5 Flash scored 76.2%, and the heavier Gemini 3.1 Pro only scored 70.3%.
Which is huge because Terminal Bench is a fantastic indicator of real-world utility. It means the model is actively interacting with a command line interface to solve a problem. It's not just generating a static block of Python.
It's navigating directories, running scripts, and reacting to the terminal output.
Exactly. And the performance on SW Bench Pro completely backs this up.
Oh yeah, on SW Bench Pro, it hits 53.9%. That is a massive jump from Gemini 3 Flash, which was at 48.4%.
It really is.
But for the listener who isn't living in these benchmarking suites every day, what does that 53.9% actually represent?
So SW Bench Pro basically evaluates if a model can act like a senior software engineer.
Okay.
It tests whether the AI can download a massive repository, read a real complex GitHub issue submitted by a user, locate the bug across dozens of interconnected files, and then write a successful pull request to fix it.
And hitting nearly 54% on that suite while operating at a lightweight latency. I mean, that fundamentally challenges our assumptions about what smaller models can do.
Absolutely.
And the general agentic benchmarks follow the exact same trend. On MCP Atlas, 3.5 Flash scores an impressive 83.6%, crushing 3.1 Pro's 78.2%.
Right. And the Model Context Protocol is essentially the new standard for connecting AI models to diverse external data sources.
So an 83.6% there means it is highly reliable at pulling data from your Slack, your Google Drive, and your local databases to actually complete a workflow.
Yeah. They also highlight Toolaflon, which evaluates real-world general tool use, where it would hit 56.5%.
Nice.
But the metric that really contextualizes the model's overall utility is GDP-Val-AA.
That's the economic value one.
Exactly. That benchmark evaluates economically valuable knowledge work, and they measure it using an ELO rating, sort of similar to competitive chess rankings.
Oh, wow.
Gemini 3.5 Flash achieved an ELO of 1656.
Which means it's beating 3.1 Pro's 1314 ELO by a massive margin.
Yeah.
It is literally producing work that holds higher economic value than a model that requires significantly more compute.
It's crazy efficiency.
But for me, if you are a machine learning engineer trying to parse massive repositories, the needle in a haystack performance is exactly what you've been waiting for.
Oh, absolutely.
On the 128K MRCR V2 8-needle benchmark, it scored 77.3%.
And then the 1 million token pointwise test is where it truly separates from the pack. It outperformed the others by scoring 26.6%.
Now, that 26.6% doesn't sound super high in a vacuum, but we really have to contextualize it.
Right, it's a brutal test.
Finding a single obscure data point buried in a million tokens of noise is incredibly difficult for any architecture. Doing it consistently at that rate makes it frontier-leading.
And this ties directly back to its intended use case. I mean, you can dump an entire legacy code base, along with 10 years of dense documentation, right into the context window.
Oh, wow.
And the model has the processing speed to rapidly iterate and reason over all of it without hallucinating or losing the thread.
But raw benchmarks in a vacuum don't tell the whole story, do they?
No, definitely not.
I mean, you can have the fastest reasoning engine in the world, but if you don't have the infrastructure to direct it, you're just spinning your tires.
Yeah, raw API endpoint isn't going to magically orchestrate a 50-step iterative workflow out of the box.
Right. And that's where Google's new agentic development platform comes in, anti-gravity.
Yeah, anti-gravity is the harness designed specifically to pair with 3.5 Flash. It is exactly how you deploy collaborative subagents.
Let's unpack the example they provided in the release, the one involving the AlphaZero research paper. Because claiming an AI coded a fully playable game autonomously in just 6 hours sounds a bit like marketing hype.
It does sound like hype, but it's really cool.
What was actually happening under the hood?
So they used anti-gravity to ingest the complex AlphaZero research paper. Then, instead of asking one AI to build the game, the platform deployed 2 distinct agents, a builder and a player.
Okay.
The builder agent read the paper and started writing the logic and mechanics of the game. And the player agent immediately took that code, attempted to play the game, inevitably encountered bugs or rules that didn't match the paper, and passed the error logs back to the builder.
So they were essentially trapped in a rapid, continuous loop of self-improvement.
Exactly. A loop of continuous planning, coding, testing, and refining. And because 3.5 Flash outputs tokens so quickly, that back-and-forth conversation between the 2 agents happened thousands of times in just a 6-hour window.
That is wild. They also showcased it transforming a messy legacy code base into a modern Next.js framework.
Yeah.
There was another example where it cranked out 6 distinct payment UI options, fully interactive, in under 60 seconds.
Which is incredibly fast.
And another where it orchestrated a whole team of specialized agents to design and build a virtual city. But I have to push back here for a second.
Go for it.
Whenever a big tech company releases a new platform, I'm naturally skeptical. Is anti-gravity just a fancy wrapper for sequential API calls?
I get the skepticism, but that is the crucial distinction to make here. Based on the documentation, anti-gravity allows for parallel multi-agent orchestration.
Okay, so not sequential.
Right. It is not a linear script where Agent B waits for Agent A to finish. You define the overarching roles, constraints, and goals, and the platform manages the asynchronous execution of dozens of sub-agents simultaneously.
So it fundamentally changes the workflow. The developer's role shifts entirely from being a writer of code to being a manager of subagents.
Exactly. You become the orchestrator of a digital workforce.
Wow.
And because 3.5 flash outputs tokens 4 times faster, these parallel subagents can converse, correct each other, and iterate without dragging the whole system to a halt.
It's like moving from a traditional post office where every letter is hand-sorted in a sequence to a massive, automated, pneumatic tube system.
That's a great analogy. You're not just moving things faster, you fundamentally change the infrastructure of the delivery.
So if the workflow shifts from writing code to managing a pneumatic tube system of subagents, how does this hold up in strict corporate enterprise environments?
It's a good question.
Because enterprises don't just deal with clean text files. They deal with messy PDFs, complex charts, and unstructured legacy databases. To run agents at scale, the model needs deep multimodal understanding.
Well, the multimodal benchmarks really confirm that capability. Okay. On SharkSF Reasoning, which tests information synthesis from complex charts without using external tools, 3.5 Flash scored 84.2%.
Let's clarify that because it's not just like looking at a picture.
Right.
The model is extracting data points from a visual plot, understanding the axis, and synthesizing a mathematical conclusion natively without writing a Python script to figure it out for it.
Exactly. It's native visual understanding. And on MMMU Pro, which tests rigorous multimodal reasoning across various disciplines, it hit 83.6%.
And we are already seeing the impact of this in their enterprise partner metrics. Let's look at Armaden, the cybersecurity firm.
Oh yeah, those numbers are fascinating.
They reported a 42% better performance on long-range multi-turn cyber benchmarks compared to Flash 3. But the real headline there is a 72% reduction in token use.
Which is massive.
Why does a token reduction matter so much in cybersecurity specifically?
Well, cybersecurity defense relies on ingesting massive, continuous streams of server logs to look for anomalies. It is incredibly token intensive.
Right, log files are endless.
Exactly. And if token usage is directly correlated to your cloud bill, running a highly intelligent agent across your entire network historically meant bankrupting your IT department.
So true.
But if you can achieve frontier intelligence while cutting token consumption by almost 3/4, horizontal scaling suddenly becomes economically viable. You can afford to have an agent monitoring every single endpoint.
Box also reported some incredible metrics, and they highlight a totally different kind of precision.
Yeah, let's hear it.
They saw a 19.6% overall improvement on their enterprise work evaluation set. But for their life sciences customers, 3.5 Flash extracted data and made calculations with 96.4% greater accuracy.
That is a staggering improvement.
And for financial services, building reports from structured data saw a 46.7% greater accuracy.
Right, and high accuracy in life sciences and finance means the model is adhering strictly to the structured data it is given.
Because you really can't mess that up.
In those fields, you absolutely cannot have a model hallucinating a creative answer or guessing a dosage. It has to act as a rigorous, reliable extraction engine, and these numbers prove it can maintain that discipline.
We also saw JetBrains report a 10 to 20% improvement in low reasoning coding performance.
Yeah.
And then there's the multi-agent deployment we mentioned earlier. Shopify is running subagents in parallel to analyze complex data over long horizons for global merchant growth forecasts.
The Macquarie Bank is using it to reason over 100-plus page documents for customer onboarding.
Oh, and Xero is a perfect example of this long horizon execution.
Yes. They are deploying agents to autonomously manage complex multi-week workflows.
Like what?
For instance, identifying suppliers and gathering all the necessary information for 1099 tax forms.
Ugh, the worst job.
Right. So the agent sends an email, waits 3 days for a reply, parses the attached PDF, realizes it's missing a tax ID, sends a follow-up email, and logs the final data.
Wow.
A multi-week workflow managed entirely by sub-agents running in the background.
So we have this massive enterprise-grade multi-agent capability running inside corporate networks. But DeepMind isn't keeping this locked in the server room, right?
No, not at all.
They are taking this high-speed agentic infrastructure and shrinking it down to fit in the user's pocket. If you're sitting there thinking, I don't run enterprise tax workflows, why do I care about terminal benchmarks? Well, think about your phone.
Exactly. Gemini 3.5 Flash is now the default model for the Gemini app in the Search AI mode globally.
That's huge.
But the much more significant announcement for consumers is the introduction of Gemini Spark.
Right. They describe Gemini Spark as your personal AI agent running 24/7 to navigate your digital life.
Which sounds intense.
It really does. It takes action on your behalf while under your direction. This isn't just a chatbot you open when you need a recipe. It is a persistent background process.
And to have an agent running 24/7, monitoring your emails, scheduling calendar events, and taking autonomous actions across your apps, the underlying model has to be incredibly lightweight, fast, and cheap to run.
While still maintaining high reasoning capabilities.
Exactly. 3.5 Flash is the exact engine making that feasible. The beta for Gemini Spark is actually rolling out to Google AI Ultra subscribers in the US next week.
Which naturally leads us to the most critical part of this entire deep dive.
Safety.
Right. If we have an AI agent running 24/7 on our phones, making autonomous decisions, writing code, and executing multi-week financial workflows, the guardrails have to be absolutely ironclad. What does the model card actually say about frontier safety?
So the ethics and content safety section provides some very reassuring metrics.
Okay, good.
In their automated text-to-text safety evaluations, which basically measure policy triggers, 3.5 Flash actually improved over the previous model by negative 3.9%.
Meaning it triggered fewer safety policy violations.
Right. It got faster, but it also got safer.
It also improved its objective tone by positive 8.9% when refusing requests. But here is the tricky part with safety guardrails, the false positive problem.
Oh yeah, that's always an issue.
Usually, if you make a model incredibly safe, you also make it incredibly annoying. It becomes overly cautious and starts refusing perfectly safe, benign requests.
According to the model card, unjustified refusals, meaning the model's ability to respond to borderline prompts without shutting down, only increased by 0.8%.
Oh, wow. That's practically nothing.
Right. So they managed to tighten the safety and tone without significantly impacting the model's utility or causing it to refuse safe queries.
Okay, so that covers the content policies, but what about the larger architectural risks?
Like what?
Well, if this thing is so good at coding and deploying agents through anti-gravity, couldn't a bad actor use it to deploy a swarm of malicious cyber agents?
That's a great point. DeepMind conducts a rigorous frontier safety assessment to evaluate exactly that. They test their models against predefined critical capability levels, or CCLs.
Okay.
Now, because 3.5 Flash is part of the Gemini 3 series, they evaluated it against the most generally capable model in that family, which is Gemini 3.1 Pro.
So they use the heavier, more powerful model as the ceiling for worst-case capabilities.
Right.
If the big model can't break the rules, the smaller model theoretically can't either.
Precisely the logic. Gemini 3.1 Pro did not reach any of the critical capability levels outlined in their frontier safety framework.
Good.
However, because the Gemini 3 series had previously reached the alert threshold specifically for cyber capabilities, they didn't just assume 3.5 Flash was safe. They performed additional, rigorous testing in that specific domain.
And what was the result of that cyber testing?
The assessment showed that even with 3.5 Flash's advanced frontier-level coding and agentic abilities, it remains firmly below the cyber alert threshold.
That's reassuring.
Yeah, it does not possess meaningful new capabilities that would breach those critical capability levels compared to 3.1 Pro.
Which is exactly what an enterprise or a machine learning engineer needs to hear. You want the advanced reasoning, but you don't want to build your entire CI/CD pipeline on a model that is constantly triggering internal security alerts.
Right, or getting bogged down in safety reviews because it crossed the cyber threshold. It ensures developers can build predictably.
They have basically created a highly capable engine for action, but mathematically constrained it within a well-defined safety envelope.
Exactly.
So if we pull back and look at the overarching theme of this paper and the Gemini 3.5 Flash model card, we are looking at a fundamental shift in the landscape of artificial intelligence.
A massive shift.
We are moving away from static reasoning, where we just ask a model a question and wait for a text response, and we are moving into the era of high-speed parallel action. The AI is no longer just a reference tool. It is an active, persistent participant in the workflow.
And the anti-gravity platform proves that the tooling is finally catching up to the capability of the models. We are officially moving from single-turn prompts to multi-agent continuous loop orchestration.
Which leaves us with this final thought to mull over. For years, the bottleneck in AI engineering was the intelligence and the token cost of the model itself.
You just couldn't do certain things because the AI wasn't smart enough or it was just too expensive and slow to run at scale?
But with 3.5 flash dropping token usage by 72% for some users, while operating at 4 times the speed, the bottleneck has fundamentally shifted.
It really has.
The new constraint isn't the AI anymore. It's how effectively you, the developer, can orchestrate and manage a massive fleet of relentless, lightning-fast digital subagents. Are your current workflows ready for that kind of scale?